Hi, and welcome back to our Lyra introductory series. In this video, we're going to be moving forward and starting our crafting mechanics. So this is an exciting moment where a lot of the subsystems come together. If you're just joining in this crafting section and you have not yet watched any of the prior 7 chapters, I would suggest chapter 1 for the organizational structure, and definitely chapter 5, which is the inventory system of which the crafting is built upon. If you don't have a strong understanding of what we've done in the inventory system, then the changes and enhancements for the crafting is going to become hard to follow along. So if you haven't watched those chapters, go back and watch those. If you have, we're going to jump right into chapter 8, our crafting mechanics. So the crafting system that we've set up is very tied into our inventory system and uses the inventory assets as its primary mechanism. It also uses the gameplay message subsystem in the Lyra starter pack quite heavily, or attempted to use it quite heavily to keep modularity between the different parts of the system and to keep it expandable. So one of the things that we needed to do was define first some C++ structs. So we ended up with 3 structs that are defined for our payloads for our messages. The first one is sort of what we're calling the crafting payload. And we found it easy to have these 4 pointers easily accessible throughout the workflow, so we wouldn't have to keep fetching the data over and over again. And so we're in the process of refactoring any of the modules where we were working before we created this first crafting payload struct to use it more frequently. The second one is a very simple, what we're calling no payload message that just simply passes a bool through just for one field, but you really don't need to use it. And then the third one was our original inventory item instance payload, which we're going to deprecate because basically the crafting payload as we go forward will be the one payload, and we'll just end up using one of the pointers as opposed to all 4 of the pointers, and therefore we don't need the extra payload. So the first step was to define the payloads for the messaging, and those were those. The next thing we defined was our crafting stations, and so as of now we have 5 crafting stations. Each station is tagged with a particular gameplay tag, which you can see in the upper right-hand corner. So each of our stations is an actor in the world. That actor has a tag on it, and that tag determines which crafting elements to present to the player when they're at that station. And this gives us flexibility that I might create a combo station that allows me to work on multiple things at the same station, or make variants of the visual station by changing the mesh components but keeping the tag the same. And so that gives us good flexibility. So the net is the player, or the system knows that the player is interacting with a crafting station based on the tag associated with the crafting station. As we think about the overall work necessary to build the crafting station, it became pretty obvious that the work is quite heavily UI based. This is kind of a rough representation of how we think the work is broken out over the 4 main areas of the solution. First being the data definition, which is where you define all of the items, all of the recipes, all of the probabilities, etc. in the data definitions. And so there's a decent amount of thought process and work that's needed to set up the data structures effectively based on your game style and approach. Second is the actual messaging flow of when we're going to send messages back and forth between different parts of the system to trigger activities. The actual gameplay ability itself was quite small. So all of the actual crafting gets performed in a single gameplay ability that is called from the UI. And then the other half of the project has all been UI work, sort of crafting the windows effectively, being able to interact with the windows appropriately in different stages of the crafting process. And so if you're thinking about the distribution of the work, really the data definition and the UI work is the bulk of the activities. So let's start by looking at some of the data. This is our sample tree of recipes. And these are the ones we've got defined for testing and will start to form the basis and foundation of our crafting system. So at the bottom of the screen, you can see our primary items that we can harvest from rocks, being stone, meat and hide from animals, wood and berries from trees. And so as in any good crafting system, as you move up the tiers of crafting, the materials get consumed and the follow-on items become raw material into higher tier components. So at the bottom, we basically can harvest out of the world these basic components at the bottom. Once I have some stone, I can go to the workstation and chip away and make bricks from stone. So stone to bricks, and the bricks feed our building system so we can build components in bricks. As a byproduct of creating bricks from stone, we may spawn some metal ore and we may spawn some rough gems. So these two are byproducts of the crafting exercise to convert stone into brick. Then we can take our metal ore, we can use the forge and take the metal ore and melt it down into metal ingots. And a byproduct of that might be sulfur. So we are starting to build up our tree of crafting recipes and byproducts. Then we can take this rough gem byproduct, use it on the workstation, create a polished gem, combine the polished gem with the metal ingot to create a necklace. And every time we try to craft a necklace, we might crit and get a golden necklace. And so we're showing a couple of different things here in the system, right? One, refining base material into more usable material, the generation of byproducts off of a crafting exercise to create even more materials, and the ability to crit a product, crit a crafting activity to make a better item. And then basically from there, yeah, it's as much as your heart desires as far as complexity and being able to add more and more items into your crafting system, and the system will just expand and grow from there. One of the things we did learn while starting to set up this data was that you can actually create base classes for your item definitions. And this became a big time saver. Instead of always having to start with a blank item definition or cloning a definition and then modifying it, we found that you can actually create base classes. And so you do that by basically opening up the item definition, which starts in a data only view, move it to open full blueprint editor, which we're showing here on screen. Then you can go to the class settings and actually create a parent class for your item definition. And what this allows is that we can set up things like the stack counts, the max stack counts, any of the fragments that are going to be consistent from item to item, the actual fragments that it starts from. We do all that in the base class. And then when we create a child class of that stuff all carries forward. So if I want to change the max stack amount for crafting from 200 to say 300, I only have to change it in one place in the base class. So the item definitions can follow a traditional hierarchy of base classes, etc. So we've opted for a base class for each primary item. So recipes have a base class, resources have a base class, equipment has a base class, etc. But it's a great time saver. Next, let's look at the fragment data structure. So every item that is a recipe has the recipe fragment added to it, where we define all the elements of how a recipe should be followed in the crafting process. So as you can see to the right-hand side of the screen, we start with what crafting station is necessary for this recipe to be crafted, whether it's consumed on use for a single-use recipe, how long the crafting duration takes in seconds, what ingredients. So in this example, I require one stone resource and it results in a brick. So I have a consumption of the resource stone at a consumption rate of 1 for 1, and it results in a brick. I can also define critical result products where we have multiple products that might crit, or byproducts that come out of this process at a prescribed ratio. So when crafting bricks, I have a 0.4 probability of getting some metal ore and a 0.1 probability of getting a rough gem. So that's the basic structure and definition of the recipe fragment. So moving past the data elements, the next major thing that we needed to consider is how are we going to use the gameplay messaging subsystem? And for those of you who haven't used a lot of subsystems, these are basically instances classes that are automatically spawned and despawned when the game goes through its life cycle. The nice thing of using a subsystem is you don't have to worry about the start and end of the subsystem. You basically have two primary events, one where a actor class will register with the subsystem, basically saying, hey, I'm listening to this subsystem, or I'm part of this subsystem, and I'm interested in things that are going on in this subsystem. And then the other activity, which is typically a broadcast, is when you're pushing stuff into the subsystem. And so this is a nice way to separate and modularize certain aspects of your system so that you can make changes to one without worrying about the impacts it has on the other parts of your subsystem. So inside Lyra, there is a gameplay message subsystem. Its parent class is the game instance subsystem. And so therefore it gets created when the game instance is started, and it'll get destroyed when the game instance is shut down. It will persist through the lifespan of an entire game instance. Over on the right-hand side of the screen, we show the two primary interaction points. So when you are sending a message into the message subsystem, you get the gameplay message subsystem reference. You define the channel, which is basically a gameplay tag. So this channel is the ability, crafting, byproduct received, and what the payload is. And so a payload is a ustruct that is defined. In our case, this byproduct ustruct is being passed into this. And then the only requirement is that the sending message, this channel, and the receiving of it have to have the same payload. So whatever payload is loaded into the message here must match this payload type here. This is how it knows which struct to break apart from the payload. So whatever goes in here on the message is what comes out here on the listening event. So that's a little bit about how the subsystem works. We primarily used two sets of gameplay tags. This first set is for basically UI to the gameplay ability and back to the UI interactions. And so we have gameplay tags called ability crafting, and we have four basic components of those tags. We have the perform craft, which is the trigger for the gameplay ability that is sent from the UI and received by the gameplay ability. And then the gameplay ability can send back any one of these three messages. It could have a byproduct that it was created. It could crafting complete, which is success criteria, or crafting fail if it runs into any issues and has a failure mode. So these four messages are really designed for UI to ability and back to UI cycle. Within the UI, we also compartmentalized many aspects of our UI so that we can not worry about references between the various elements of the UI. And then these are the actual messages that we ended up with from a UI event. So we have a UI event crafting, and then underneath it, these various messages, which we'll see as we go through the code and look at when all these things are occurring. But we're using that message subsystem to basically modularize our UI into different components, with the idea that we could sub out different components at a later date and not have to worry about the hard wiring. So with data and the messaging system out of the way, the next component was the actual gameplay ability. So the gameplay ability is actually where the crafting occurs. It actually only crafts on the server. However, all the steps are performed on the client except for the actual crafting step. This is so that any messages that are created that trigger UI events are created on the client, and therefore the UI will simulate the activities that are occurring on the server. The server will always override the client if there's a discrepancy between the server and the client. But it's important to know that the gameplay ability runs. It runs all activities on the client and on the server. The server is the authoritative one, which actually makes the changes to your inventory. And if there are discrepancies, will overwrite the client inventory. So 4 basic steps in that ability. One is our standard setup where we're just checking that everything is valid before proceeding. We then go through a routine where we check to make sure you have all the appropriate ingredients. It's important to do a check on the UI for the user and to flag any errors for the user on the UI, but it's also important to check once again on the server to make sure there's no cheating going on and that the ingredients are in fact in the inventory on the server for the player requesting the crafting. So we do a complete ingredient check first. If we pass that, we then move into consuming those ingredients. And the reason we separated the two is we didn't want to start consuming ingredients and then have to roll them back. So the check makes sure that everything is there before we attempt to craft. Once we go into the consume, we consume all the ingredients, we generate the new item, and then we broadcast back the creation of the or the success of the event. So we'll explore this a little bit more when we go into code, but this is how the gameplay ability is generally structured. So as I said, the vast majority of the work is in the UI. Right? And if you think about crafting, 90% of the user's interaction with the crafting system is through the UI. Traditionally, there may be other ways where you might want to do different things, but traditionally there's a UI for your crafting, which brings together all the elements and allows you to interact with it. So our main interface is divided into 3 primary sections. The left-hand side is our recipes that are known by the player, and there'll be a card for each of those known recipes. When they click that recipe, it gets loaded into the workspace on the right-hand side, and that's where you will actually perform the crafting activity. And then as a courtesy on the bottom of the right-hand side, we show what ingredients are available in your inventory. And so right now, we are not filtering those beyond just the resource tab. We may actually choose to filter them even more so that they're only ingredients that are necessary for recipes that are available at this station. But for now, it's a simple list of the overall ingredients. You can see across the top the various widgets that are part of our overall flow. And on the left-hand side, sort of a rough grouping of the recipe list and its recipe tile button. So the list has multiple occurrences of the recipe tile. The action area has 4 different sub widgets that are part of that overall layout. And then our ingredients is our standard list of ingredients. So that's kind of a quick overview of how that is. We're going to spend most of our time in the code looking at the way we crafted the UI. One other thing to note before jumping into the application is we needed to clone one of the Lyra buttons. So the Lyra tile button is this button that you see throughout the system. It is well formatted and clean, has good animations attached to it, triggers well. Unfortunately, it relies upon a vertical box, as you see highlighted here. So the choice we made was to actually clone the Lyra tile button and make a Lyra horizontal tile button, which replaces the vertical box with the horizontal box, moves some margins and borders around a little bit, but that became the base class for our recipes. So we have the Lyra tile button, which is the base class for our craft button, and a new Lyra horizontal tile button, which is a copy and paste of the Lyra tile button, switching it to be a horizontal box and then switching around a few graphical elements to make it fit and feel better. All right, so with that, why don't we jump over to the editor and let's see the crafting system in action. All right, so we're in the editor, and let's perform some crafting first. So there are the stations that I referred to. Piles of resources are on the ground. My character already has all the crafting recipes that he needs in order to perform any of these crafting exercises. So basically from here, we're going to do a couple crafting. So the first thing I'm going to do is pick up this pile of stone, interact with the workbench, and you'll see I have 50 stone. We're going to go ahead and craft, let's say, definitely need to get a little plus minus on there. Let's do 12 stone bricks, which will consume 12 stones from our 50 available ingredients. So once we start crafting, you'll see I immediately got a byproduct, another byproduct. Remember, the green byproduct has a 40% probability. The blue byproduct has a 10% probability. So crafting will continue until I've completed the crafting queue or I hit the cancel button over top of the crafting icon. And I believe I said 12 when we started. So we're doing our last craft. And you get the audio cue that you're done your queue. We ended up with our 12 stone. We actually got 7 byproducts for the metal and 1 byproduct for the rough jewel. I go grab some more metal ore. In this case, I'm going to hit, so this is a complex where I might need 5 ingredients to make that. In this case, we're going to hit the metal ore. We'll craft 5 of those. And in this case, what we'll do is we'll be in the middle of the second one. We'll cancel it. And it'll basically cancel out after doing the second crafting. Finally, let's go to the crit. We'll pick this up so we can make some jewelry. And we'll make, let's go with, I think the crit rate's pretty high. Let's go with 7. So you should see purple versus gold if I get a crit. There's a crit. Nicely done. So there we... On crit, I lose my cancel. So there's a bug when I crit. All right, so I ended up with 5 necklaces. I need to do a wrap text on that, and 3 of the golden necklaces. So, yeah, there's a few little kinks that need to be worked out still, but essentially that's how the system works. You gather up your resources, you approach whichever crafting station that you require. If you know recipes, they'll list here. You'll see your ingredients here, and you'll work primarily in the workspace. All right, so let's go from here and go look at the code. Maybe we'll find our crit bug. All right, so let's take a look at some of the classes. So within our ability core, let's go ahead. Within our plugins, within our ability core, we have 3 primary locations. Under our game, we have our crafting ability, which is where all the crafting activity occurs. We also have simple abilities that toggle the windows for each of the crafting stations. Under our items, we have our recipes, which all inherit from the recipe base class and then define the various different aspects of each and every recipe. I'm not going to spend time on that. We just talked about that. And the UI for crafting. So in the crafting UI, let's go to the elements. The available inventory is no different than the material we shared in the inventory system where we were showing the inventory grid. So there's nothing radically new there. I will show, let's go into the crafting button first. And the crafting button is basically a button that when you click on it, this one is inherited from the Lyra tile button. So the Lyra tile button, if I zoom to that, has a great deal of logic that are all primarily visually oriented. So everything the Lyra tile button is doing is playing animations forward and backward on hover, doing some animations when you press, playing some animations when you select or deselect. And so this button is a good base class for our crafting button. And so we made a child of the Lyra tile button. And there's only two functions that we need in here. First, when we click the button, we are going to do a quick disabled check. If it's not disabled, we'll perform the parent call, which performs all the visual activities. And we will broadcast the UI event crafting request crafting. So when I hit the button, here you see the gameplay message subsystem being invoked. We're passing one of our UI events, which is requesting that we start crafting. The only other thing this button is doing is on initialize, it's listening for any of the gameplay messages that it cares about. So one of the messages it cares about is its own message request crafting. So right here, I say, I want to start crafting. Right here, I pick up that message and I disable the craft button. So immediately upon receiving the message, the craft button goes disabled. You can't craft again until the crafting queue is done or you cancel. We then listen. So these are chained together, not on the on message received, but chained together in sequence. We then listen for the queue to be finished. If the queue is finished, we turn our button back on. We also listen for cannot craft the selected recipe, in which case if we try to craft, but the recipe, we don't have the ingredients for the recipe, we enable the button again. We don't actually perform any actions. And we listen to the can craft selected. Sorry, we disable the button and we enable the button. So these four messages are enabling or disabling the craft button. And all of that logic is containerized inside the button itself. So I don't have to call anywhere in any of the other code. I don't have to go get the button and I don't have to set the button on or off. Just by firing the respective message, the button will respond accordingly. That's probably the simplest one. If we look at our recipe tile button, this is the one where we made a horizontal version of the Lyra button. We basically just override the default sizes here. We do the initialization and we listen for our messages. This one is very similar to the other button. I want to know if I'm requesting crafting, if I've queued, if I finished a queue, or if I craft failed. So exact same logic as the craft button. These two buttons function the same way. The difference is that the recipe tile button inherits. Sorry, it does. Yes, it does inherit. It inherits this interface user object list entry so that this button can be placed in a object list. Because we have that interface, we have access to this event on list item object set where we pass in the item instance, cast it, cache it, find the recipe, find the icon visuals, load the name, description, find what the fragment class looks like, grab its icon, and set it up as a texture. So all of that logic basically formats each copy of a recipe tile based on it being added to a list. So the important aspect is you need to have the user object entry list interface on the button. That will create this node. You then do all of your visual graphics off of that node. The only other thing we have, which is similar to the other event, is on click. Assuming we're enabled, we call the parent for the visual effects, and then we do an on selected recipe. That basically does a message. So when I select a recipe, the UI triggers an event, recipe selected. So I'm not actually doing anything in the selection of the recipe other than firing this event off into the message subsystem. Now I happen to know that that event is listened to in our action area. So if I go to the action area, which is this area where the recipe gets loaded into, and I go to its graph. So on the event graph, this is where most of the logic is occurring. It's probably easiest to start way down here. So when the action area is initialized, we hide the canceled window. We don't need to see that right away. We clear any recipe that may have been lingering from our last recipe, which simply is just hiding these elements. And then we listen for the recipe selected. So the button sends the recipe selected. The action area is listening for the action area. And when it gets the payload, which is what item I clicked on, that payload is broken. We validate it. We populate the recipe details on the screen. And then we set our slider limit based on the recipe and how much raw material we have for the recipe. So just to take a quick look into each of these, populating, we're basically going through grabbing our components. We're populating our resulting item widget. We're putting in our description. We're putting in our name. We're formatting our duration, putting that into our duration field. We're making our recipe overlay visible. We're hiding our instruction, and we're enabling our craft button. So those are basic activities. And then on our limit slider, we basically loop through, start with an extremely high constraint. So in this case, we're looking for numbers that'll be smaller than this. So we start with a very high number. We get the first ingredient. We determine what the ratio is. If that number is lower than our current max count, which in all likelihood it is, it might be 10 or 15 or 20. We make that our new smallest counter, and we loop back in looking for our next ingredient. So if I have 3 ingredients, I might start with 999. The first ingredient might say, okay, you can make 50 of these. So the number goes to 50. Then the second ingredient comes through and says, oh, you can only make 10. So this comes out and the max count is dropped from 50 to 10. And then the third ingredient says you can only make 2 of them. So the 10 gets dropped to 2, and that's what we pass back at the end. So at the end, we basically set our min and max to the lowest number of ingredients that we have in order to craft. And then we set either we can or we can't craft. So if we got to 0, then we tell it we cannot craft. So that's how those messages are flying back and forth. And again, to show you that, let's pop back in with what we just discussed. So if I'm disabled to start with, my message text is here. If I select a recipe, it'll fire a message. That message will be picked up by this panel. this panel will then format this area and send its own message. Either I can or I can't craft this item. So for example, if I were to hit the polished item, I can't craft it, and therefore this is not interactable. So message fired here, received and formatted here, determined I cannot craft it, therefore this is disabled. Same workflow if I click the stone brick, information loaded into the action panel. Now I can craft because I have at least one stone. In fact, I have 50. So in this case, I can craft. Crafting completes, and all the messages fly. So let's go look at a bit more of that. So when I click the craft button, the message is received. Sorry. So this was me clicking the recipe button. If I change the slider for the quantity, then I'm actually changing the quantities in the ingredient box. So if I receive a quantity changed message, then the ingredients box gets updated. So there's actually no connectivity between the slider and the quantity box other than the message that gets passed through the action area. So taking a look at how that transpires. As I change the quantity box, it's triggering off a quantity change message, which then in turn is processed by these ingredients list. So as I slide the bar over, I get more and more items in the ingredient list. In fact, if I had a more complex, where I have two ingredients, you'll see that both numbers are going to increment based on their consumption pattern. So this message is firing, this box is picking it up, it's applying whatever logic it needs to into the visual, and the two boxes don't know about each other. All right, back into our area. We've now changed our quantity back and forth. We might receive the request crafting from our craft button. If that's the case, we're going to initiate our crafting loop. So we're going to go in here. We're going to start listening for a cancel. There's no point in listening to a cancel until we've actually received a request to craft. So we reset those variables. We listen for cancel. If we get a cancel, we turn our cancel on. Until we cancel or complete, we're basically in this pseudo loop. So as long as I have something left in the queue and the user has not requested to cancel, I'm going to process and then perform a craft. So I'm going to run the timer down and perform a craft. And the rest of the process flow is consistent where messages are sent and received. So in this case, we're having the byproduct be received. We get our byproduct. We set our byproduct icon. I'll show that in a second. And then we play a animation. We wait a few 0.4 seconds, and then we play the sound effect. So you'll see that on the UI. So let me actually go to that. So we have this sort of starts off invisible byproduct visual that when we play the animation, let's get this into proper frame. When we play the animation, we're basically moving through the scale, transform, and opacity, and then scale to create the effect of the byproduct being crafted, moved, and then ultimately given to the player. So this animation sequence, and there's the same one for the main product, is triggered right here when I get a byproduct received from the gameplay ability. we paint the icon with the appropriate picture, and then play the animation, play the audio effect. So that, and then again, there's a few more, but this is basically the same thing. Each of these chains is triggering off of a specific gameplay message and performing whatever actions it's necessary. In some cases, it then broadcasts a message at the end of its chain, which may or may not trigger other actions in the system. So let's take a look at, well, let's start here. So when we perform crafting, we basically send the gameplay event to actor, to the ability system on the player state. We send the ability crafting perform craft. This was the first tag we talked about where the interaction between the UI and the gameplay ability is triggered. So we send in the actual item that we want to craft through the payload, through this gameplay event tag, which is picked up in the perform. So this is all the crafting. So let's go first here. So as I showed earlier, this gameplay ability is triggered when this tag is sent to the owning actor, which then initiates this gameplay ability. We commit the ability, we get the event data, we do our normal checks and balances to make sure that everything is valid. And then we have our two main blocks. Do we have the ingredients? Yes or no. And if we do have the ingredients, we actually perform the craft. So do we have the ingredients? We basically, and this is a very common pattern, you start with an assumed state. That assumed state is when we have not failed. So this is true until we do fail. We grab our ingredients. We determine how many ingredients we need. So in this case, for this particular item, I might need 2 of this ingredient. We perform this function. If we have enough, we go back and get the next ingredient. If we don't have enough, we assume fail. And we break out and return our confirmation. The do we have enough is a little bit more complicated logic because we may have multiple stacks and multiple stacks may not be in sequence. And so I might have my first stack have only 1 item stack on it, and my 5th or 6th item in my chain may have 10 or 12 or 14. And so we can't assume that we just grab the first stack and that's good enough, because we may have multiple stacks, and across those multiple stacks, we may have enough ingredients to craft this recipe. So this logic basically looks very similar in pattern. So we have a temporary counter that we set to 0. We grab the items out of our inventory, and we loop until we have enough. So we start by grabbing the first element. We check that it matches what we're looking for, and we check that it's in standard inventory. It's not in our storage, our bank. It's on our person. If both those are true, we grab the item stack count off of that item, add it to our running total. So we basically take our running total, add the stack count. This is our new running total. And we determine, is our running total enough to cover what we need? If it's true, we're going to break the loop. If it's false, we go back and grab the next item and keep looping until we either get through all of the items or we get enough count off of our stacks that we're good. Once we break, we can come out of the cycle. We check if we have at least enough. If we do, we're good. Probably best go back here. So we loop through all of our ingredients, checking multiple stacks, making sure that we have enough ingredients of all ingredients in our inventory. If that's true, we then are going to perform our craft. So in our craft, we go through each ingredient. In this case, we're removing the stacks. So we're no longer counting and checking if we have enough. We did that already. Now we're going in and we're saying, okay, go take out those ingredients. And so this step says, I'm going to use this adjust inventory stack routine to remove X number of stacks from this particular item definition. And I do that for all of the ingredients. Once I've completely removed all of the ingredients, I then determine whether or not I'm going to have a crit event. So I can either crit or not crit. If I crit, then I'm going to get the critical item. If I don't crit, I'm just going to get the default item. And so that becomes the item that we end up handing over in the inventory. So here we make the new item. So instead of removing stacks, in this case, we're adding a stack of 1. So this item gets added in. It may get added into an existing stack. It may form a brand new stack. That's all handled inside of this routine. And then we evaluate our byproducts, as we may generate one or more byproducts as well. So all of this activity of whether I crit, adding the new item, and then evaluating the byproducts all happen inside the gameplay ability. Crit, it's not that complicated. We loop through all the critical potential items. It may be blank, in which case we get none. We're determining if we crit or not. So we take that array element. Oh, this is important. In order to do random number generation, you need to have the client and the server generating the exact same random number so that the visual effects on the client and the resulting item on the server are the same. So you do that by using a random stream seed that's replicated. So yes. At the very beginning, when this ability is granted to the player, if we are the server, we generate a random number between 1 and 100,000, then generate a random seed stream from that random number, and store it in this value, which is then replicated to the client. So both the server and the client have this exact same random stream seed value. Therefore, when I use the random float in range from stream, they will produce the exact same result. We cannot use this node because this node will produce a different result on the server and a different result on the client. All right, so we determine whether or not we hit the probability of the crit. If we do, we say we crit. This is the critical item, and we exit the loop. As soon as we crit once, we're not checking any other crit conditions. And so it's important to stack them in the array in the sort of highest to lowest priority. So if I have a super crit, I want that in element 1 or 0. And if I have a secondary crit that's not quite as good, I put that in element 2. So the first crit we hit, we pass back out of this routine. That then either replaces the item definition with the crit item definition, or we pass through the standard. We make the new item. This is a little scary. Because of our stacks and the potential to have any variations of the stacks in inventory, there's several conditions we had to account for. I'll run through it quickly. First of all, this only happens on authority. Like I said, all steps are performed on the client and on the server, except for this one step. This one step, which is the actual adjustment of our inventory stacks, only occurs on the server. We get assigned the number of stacks we have to process. We're either adding or removing a certain number of stacks. And we have an item definition that's passed in. So we grab our inventory and we're going to process it front to back. So we go into our control loop. We discard anything that's not of the same definition, and we discard everything that's in storage. And so by the time we pass this gate, we have the right item and we're not in storage. So it's a potential. We then branch into one of two paths. If we are removing stacks, then we're going up this chain. If we are adding stacks, we'll go down the false path. The add is easier than the remove. So first thing we do is we determine how much space we have left on this item. The item that we just got, we want to add one to it. It may already be a full stack. If it's a full stack and I have no room, I need to discard it and move on to the next one. So we're going to check our available space. We're going to determine if we have enough space for the number of stacks that we want to process. So we might have room for 20. We might have a stack of 10. That's all good, and we'll be able to finish. So if it's true, we're going to add those stacks in, and we're basically setting our stacks to process to 0, and we've processed everything, and we can exit the add. If we don't have enough room, if the available space is less than the stacks to process, means I'm going to have something left over. There's two conditions. If the available space is 0, sorry, I said greater than 0. So 0, we simply go get the next stack. This means the stack is full, and we're just going to move on to the next stack. On the other path, I'm going to go ahead and use up all of the available space that is on this current stack. So the example that I need 20, but I only have room for 10, I'm going to put the 10 on this stack. That fills it to the top. And I then say, okay, how many stacks do I have left to process? So my stacks to process shrinks, and we go back trying to get another item. And we continue that until we pass through all of the items, or our stacks to process gets to 0. In those cases, let's come down this path. If the stacks to process, we still have some, we'll follow this path. If we were removing stacks, that's a problem. If we were adding stacks, then we simply need to add one more item definition. We need to create that brand new stack, which is the same way we did it in the inventory system, where we add the definition, which automatically adds a single stack, and then we add the balance of the stacks via the add stat tag stack. So the add conditions could be no stack at all, could be full stack, partial stack, enough to fit this one, not enough to fit this one. All those are handled through that logic. On the remove side of that equation, so very similarly, if we hit this branch point and we're removing, we're going to come up and run this logic up here. This logic shares a lot of characteristics with the add. We basically get what's our stack count. In this case, we don't need to know the max because we're removing. We're trying to work our way down to 0. We determine how many we have available and how many stacks do we have. Let's say we have 50. We determine, do we have more available stacks than we want to take away? If the answer to that is true, we simply remove those stacks and exit out of the equation. There's nothing else to do. If, on the other hand, we don't have enough in this particular stack, we're going to come down to another branch. We're going to determine, do we have equal stacks? If we have equal stacks, in other words, miraculously, the stacks to process is 10 and the available stacks on this one is 10, then I'm simply just going to remove the item right out of the inventory because we've consumed all the stacks, set stacks to process to 0, and exit. The third scenario says that these are not equal, which means we have to consume everything that was on this stack, but we still have some left over. So then we compute how much is left over, and we go get the next item and complete the process until we get to 0. So this routine, the adding and removing of stacks, is kind of the heart and soul of the gameplay ability, which is called twice. Once when we're trying to remove ingredients from the ingredient list, and the second time when we're trying to add either the critical item or the resulting item. Oh yeah, and there's a third time. And once inside the byproducts. So exact same thing. If I have a byproduct defined, I'm going to use the same seed logic to determine whether or not I generate a byproduct. If I do generate a byproduct, I'll use that adjust inventory stacks to add the byproduct in. And then I will trigger the byproduct received message, which is a message that tells the UI that it's going to be drawing 2 items received. So, or more. If I have multiple byproducts, I can get multiple. So this is the event that triggers the UI. We come back to the UI upon crafting complete. Upon byproduct being received, we'll set our byproduct icon. We'll run our byproduct animation, and we'll play our byproduct sound effect. So all of that working together. Now let's do this one. Stone. You'll see each time I craft, the stone moves over. If I hit a byproduct, I'll get 2 images crafting over. There you go. All right, I think that is most of the crafting system. If there are other things that I think of that I didn't showcase when I look at the video back, I might make a supplemental. But hopefully that covers the overall design paradigms, how we structured the crafting system, how we then set up the data structures, the data elements in item definitions, how we use the gameplay message subsystem to route messages between different parts of the system, the actual gameplay ability that does the crafting, and then a glimpse into the UI work that uses a lot of the Lyra base classes and extends them to be a more robust crafting system. So once again, thanks for watching. Leave a comment or a like, and we'll move on to the next chapter. Thanks again.